We're going to be looking at an internal resistance problem, multiple choice question. These can be tricky, so let's have a look. The first thing is to just look at what we're given. We're given the circuit diagram there. We're given the EMF of the cell, which is 5 volts, and we're given the internal resistance of the cell, which is 10 ohms. We're also told that there's 1.8 volts potential difference across the LED, and we're given the current in the circuit, which is 20 milliamps. So it's a good idea to get everything onto the circuit diagram there, so it's all in one place. We know that when there's a current flowing through the cell, and the cell has internal resistance, then there's going to be lost volts across the cell due to that internal resistance. And it will be a good idea to calculate that first, which we can do from V equals I times R. And we know the current is 20 milliamps, and we know the internal resistance is 10. So that's going to give us 20 times 10 to the minus 2 volts, or 0.2 volts. So we can mark that on here. The next thing to do is to consider the PDs around the circuit have to add up to the EMF, one of Kirchhoff's laws. So we know that the EMF for 5 volts would have to be equal to the lost volts plus the PD across the LED, which we're given, plus the PD across the resistor. We can substitute the values in. So 5 equals 0.2 volts plus 1.8 plus our unknown, and then a little bit of just rearranging of that. We get 5 minus 0.2 minus 1.8, which equals 3 volts. So we found the PD across the resistor now, and it's 3 volts. We know the current through there is 20 milliamps. So we can use R equals V over I relationship now. And we've got 3 volts over 20 milliamps. Use our calculator. That's going to give us 150 ohms. So the answer is C.